Why, more than half a century after the first moon landing, is it still so challenging to land on the moon? It's a question that has puzzled many minds, and today we're going to delve into the underlying factors that make lunar touchdown such a tricky business. Let's start with the first challenge: the moon's weaker gravitational pull. This might sound like a good thing, right? Less gravity means less force pulling you down, which should make landing a piece of cake. But in reality, it's not that simple. You see, when a spacecraft is hurtling through the vast expanse of space towards the moon, it's moving at incredible speeds. Now imagine trying to slow down this speeding bullet of a spacecraft for a smooth landing. It's like trying to stop a freight train on a dime. This is where gravity comes into play. On Earth, our stronger gravity helps slow things down. But on the moon, with gravity only about 1/6 that of Earth's, slowing down becomes a formidable challenge. This weaker gravitational pull means that a spacecraft has to do a lot of the heavy lifting, or in this case, heavy slowing itself. It's a delicate balancing act, trying to counteract the spacecraft's forward momentum while not using so much force that it sends the craft hurtling back into space. It's like trying to balance a pencil on your fingertip. Any slight overcorrection can have disastrous results. And remember, all of this is happening while the spacecraft is millions of miles away from Earth, meaning any adjustments have to be calculated and executed with pinpoint precision. There's no room for error, no second chances, it's a one-shot deal. So, even though the moon is a lot closer than Mars, its low gravity makes landing a spacecraft there as tough as nailing a three-pointer from half court. But don't worry, we're not stopping there. Stay tuned as we continue to unravel the complexities of lunar landing in our next segment. Once you've managed to slow down your spacecraft, the next challenge awaits: the moon's surface itself. Now you might be thinking, it's just dust, how bad could it possibly be? Well, let me tell you, it's not just any dust. This is lunar dust we're talking about, and it's a whole different beast. Imagine this: you're about to land on the moon, your heart is pounding, you're focused on your instruments, and suddenly, your visibility drops to zero. Why? Because the moment you ignite your descent engines, you stir up a cloud of lunar dust, and this dust doesn't behave like the dust we're used to on Earth. It hangs in the air, obscuring your view, making the landing even more challenging than it already is. But that's not all. This dust isn't like the soft, fine particles we're familiar with. Lunar dust is sharp, abrasive, and can be incredibly damaging to equipment. It's been described as being akin to finely ground glass, and if that doesn't sound pleasant, it's because it's not. This dust can infiltrate every nook and cranny, causing all sorts of problems. It can erode spacesuits, clog equipment, and even interfere with machinery. It's so pervasive that during the Apollo missions, astronauts reported that it got everywhere, even inside the spacecraft. And to add to the challenge, this dust isn't just lying around on the surface. It's embedded in a layer of what's known as lunar regolith, a mix of dust, soil, and broken rock. This regolith can be as fine as talcum powder or as coarse as gravel, adding another layer of complexity to the landing process. So you see, landing on the moon isn't just about getting there. It's about dealing with an environment that is utterly alien to us. An environment that includes a surface covered in what can essentially be described as microscopic shards of glass. This lunar dust, or regolith as it's technically known, is so tricky that it's been likened to a layer of microscopic glass shards. Not exactly the welcoming committee you'd want after a long journey through space. So you've navigated the moon's low gravity and dealt with the dusty surface, but the challenges don't stop there. We now step into the realm of technological trials. The moon landing is not just a physical journey, but a technological ballet, performed with precision and grace, in a setting that is as unforgiving as it is inspiring. Imagine trying to land a plane on a runway in the middle of a storm, with no visibility, and having to rely solely on your instruments. Now multiply that complexity by 1,000. That's what it's like to land on the moon. The navigation systems must be precise to the point of perfection. Even the smallest miscalculation, a tiny error in angle or speed, can lead to disaster. It's like threading a needle from miles away. Then, there's the communication with Earth. We're talking about 250,000 miles away. That's a long-distance call if there ever was one. And it's not just about saying hello. The spacecraft needs to send and receive crucial data, updates on its position, its health, its every move. And it needs to do it in real time, despite the immense distances involved. And let's not forget the equipment. The lunar module, the spacesuits, the tools, they all have to withstand the harsh lunar environment. The extreme temperatures, the lack of atmosphere, the radiation, everything out there is trying to break them down. They have to be built to last, built to perform, and built to survive. But it's more than just surviving, they have to be versatile. The moon is a world of unknowns. You need equipment that can adapt, that can face any challenge that this alien world might throw at it. Technology is the silent hero of every moon landing. It's the unseen hand that guides the spacecraft, the voice in the ear of the astronaut, the shield that protects them from the lunar wilderness. From the moment a spacecraft leaves Earth to the second it touches down on the moon, it's a constant battle against the odds, with technology playing an instrumental role in overcoming these odds. The moon, our closest celestial neighbor, remains a challenging target for space missions, even decades after the first successful landing. Our journey today has taken us through the unique challenges that make lunar landings so notoriously difficult. We've grappled with the moon's low gravity, a force so weak it makes navigation and landing a complex ballet of precision and control. We've battled the abrasive lunar dust, a seemingly innocuous substance that in reality poses significant threats to both equipment and astronauts. And we've navigated the technological tightrope, balancing the need for advanced, reliable technology against the constraints of weight, cost, and the unforgiving environment of space. Each of these factors contributes to the intricate puzzle that is lunar exploration. As we continue to push the boundaries of space exploration, it's clear that the moon, despite its proximity, still holds many challenges that require our ingenuity, perseverance, and technological prowess to overcome.